All right, let's go over the free response. And number one, you have a classic oil kind of coming into the barrel and then leaking out of the barrel. Very popular amongst AP. So you have that it's coming in at B of T, and then it is partially cracked, so it's draining out by D of T. And there are 30 cubic feet of oil in the barrel at time T equals 0. Again, as you read, I want you to think of, emphasize units, and that will get you going. Read carefully. How many cubic feet of oil funnel into the barrel during the 8-hour time interval? Funneled into. So which one is that? That's B of T. Remember to write quickly and efficiently. I'm just not going to write the whole equation again. I'm just going to write that right there. And I'm going to then go to my calculator. Just for time's sake, I already typed in what's in Y1 and Y2 there, the two functions, if you want to note that on your paper so you remember. But I'm going to, of course, just do math 9. I'm going to integrate from 0 to 8 of Y1, and that's going to give me my answer. Anytime I do a definite integral, I have to have the integral on my paper. 76.570 cubic feet. Because again, if you have cubic feet per hour, the units are cubic feet per hour, dt times hour. Those cancel. I end up getting cubic feet. So that is my answer. You get 1 point if you integrated the correct thing. So +1 for that integral, or for having the integrand correct, and then 1 point for getting the correct value. Part B. Is the amount of oil in the barrel increasing or decreasing at time T equals 3? Give a reason for your answer. You can actually do this a couple ways, but again, if you're talking, you basically have to see, okay, let's think about that. Is the amount of oil in the barrel increasing or decreasing? Well, that would depend on if more is coming in versus draining out, or is more draining out than's coming in. That would tell you the difference. So this is how I probably would, I'm going to write it two different ways, but I would probably do this. B of 3, you're going to look at the rates at D of 3. You have to consider what's going on with the rates. And remember, B of T and D of T are the rates. So to get those things, of course, I'm just going to go Y1, that was B of 3, and then Y2 of 3, and that would give me D of 3. So I'm going to copy those numbers. Anytime when you can get a number, you don't want to say, oh, this one's bigger than this. You're giving mathematical proof because you're not guessing, you're proving. So because you have these two numbers, I would then say, since B of 3 is less than D of 3, in other words, the rate at which it's coming in is less than the rate that it's leaking out, the amount of oil in the barrel is decreasing at T equals 3. So I would definitely, please look at my notation and make sure you understand where I'm getting those things. As far as what the points are, is that 1 point was if you considered both B of 3 and D of 3 in some way. And then, of course, answer with reason. So you can't just say, if you said it was decreasing but don't have a correct reason, you won't get the point. The other way you could have justified is some people like to compare it this way and do B of 3 minus D of 3, and it was a negative number. You could have just found that, Y1 of 3 minus Y2 of 3, it's negative, which is less than 0, which means, of course, since that the rate there is negative, then same really words there, but the amount of oil is decreasing. So again, it's the rate coming in versus the rate going out and seeing if that is positive or negative. Okay, very good, very good. Letter C. Oh, goodness gracious. There it is. At time t equals, at what time, t being 0 to 8, closed interval is the amount of oil in the barrel at a minimum. Justify your answer. Here it is. I'd bet money that it will be on your AP test. Good old candidates test. It doesn't say absolute but remember, if it doesn't say absolute, it's understood. If it is relative, it will say that. And you have a closed interval. So let's think. It said minimum. So I like to write the candidates for absolute min are endpoints, and when B of t minus D of t, because this would be kind of what we talked about up here, changes negative to positive. Again, I could say equal to 0, but to me, I like to not even bother with the ones that are going to be a maximum because it just wasted time. So it doesn't take that long to write that. So I'm very specific as to what my candidates are. So I need to find out where that is. I need to find B of t minus D of t. Where is this equal to 0? And I'm going to use my calculator. I don't know why I changed colors, but I'm going to use my calculator for that and see where those things. So I'm going to actually turn these off just because I like to compare to 0. I don't want to have to search my y. So that's why I did it this way. Where is y1 minus y2? So I'm going to see where that is equal to 0. So I'm going to go ahead and put that into y4. I'm going to go to my window and set it at my time, 0 to 8. And then because I'm going and seeing 0, that's why I like to do that. I'm just going to put my y's from negative 2 to 2. I am going to graph, and I am going to find where that is going from negative to positive. Okay, so let me find where that is. Second calc intersect, and I'm going to find that value right there. Perfect. So remember, you have to defend why something is a candidate. I think 0 is also where it equals 0, but it's an endpoint anyway. So in my t-chart, I like to do a t-chart. My 3 values are going to be 0, 3.272, and 8. And then what is this? What am I finding the minimum of? You don't have to write a formula because I haven't defined it as anything. I'm going to say amount of oil in the barrel. Now let me think for a second because I've got to figure out how to find that. Now, I know that this value is 30 because they told me that. It said there are 30 cubic feet of oil in the barrel at time t equals 0. Now, how would I find what's in? Now, remember when we found this value, that was how much came into the barrel. I didn't consider what was going out. So are you with me that what I'm going to do, I just want to write this out, is the amount of oil in the barrel. I'm going to take the original 30 and then I'm going to add the integral from 0, and I'm just putting a letter there. B of t minus D of t. What's coming in minus what's going out. I don't care what letter you put up here. I'm just putting these values. I'll put C for candidates. I don't care. Or put D for, I don't know. Well, I don't know. Whatever letter you want. I think I put P for Pruitt. Whatever letter floats your boat. But here's the deal. So for this 3.272 or 8, I've got to figure out how much oil is in the barrel. So remember that I put, number one, remember that this value is stored into X. And that's going to be what's going to be up here in my, so let me write this one out just to make sure you follow me. This one is going to be 30 plus, not that I would have to write it out twice, but 3.272 B of t minus D of t. That's what I'm going to have to do. Remember that I put y1 minus y2 into y3. So what I'm actually going to type in the calculator is going to be 30 plus math 9, 0 to x, because that value is stored into x, and then alpha, I believe I had it in y3, dx, and that's going to pop out my number of 27.965. I'm going to do the same exact thing. I'm going to just hit second enter so I don't have to retype all that. I'm just going to change that number right there to 8, and it's going to pop out 48.547. And then I'm going to read the question again and answer it like using words from the problem. At what time is the amount of oil in the barrel a minimum? At T equals, I'll probably start this. There's my minimum value. I'm looking at these three values. At T equals 3.272 hours, the oil in the barrel is at an absolute minimum. And I don't know, I like to put, they like you to put these things. So I tend to put those in my answer. And there you go. Now let's talk about the points. That was a long explanation. Let's talk about the points here. So number one, it was, this is kind of hard to understand, but you had to have all this stuff here. So did you consider B of T minus D of T? Did you know to do that? And then really they say answer. Did you get this answer? But you have to have the justification. So it's the answer and then 1 for the justification. Now let me say this. If you said, got this correct answer, where, oh, I got 3.272 because the derivative changes negative to positive, you would get 0 credit for that. Okay, not any. So to justify an absolute, friends, pretty much what I've written down is what would have to be on your paper. That's why it's so hard to get all the points for that. But you can do it. Okay, the justification is the chart, all that stuff, everything labeled, why things are candidates, all that stuff. Okay, but there you go. Okay, the barrel can hold 50 cubic feet of oil before overflowing. For T greater than 8, oil continues to flow into and out of the barrel at the given rates until the barrel begins to overflow, right? But do not solve, love it when I see that, an equation involving one or more integrals that gives the time M where the barrel will begin to overflow. So what does that mean? Well, okay, the barrel can hold 50 cubic feet of oil. Here, I mean, the barrel has 30 cubic feet, 27, we're getting bigger, 48.5. The question is, at some time, this number is going to be bigger than 50. So I basically don't know what time that is. Now they said at what time M, it's when this value is equal to what? 50. Now that's what I would write down. If you did some math in your head where you wrote like the integral from 0 to M, B of T minus dt equals 20 because you thought, oh, it started with 30, so it only has 20 to grow. Yes, you would get credit for that. What the points are is, did you know to write this correct integral? Did you have that integral? You knew to integrate B of T minus D of T from 0 to M. And then did you have a correct equation? Again, that could either be like I had it, or if you did the subtracting of the 30 and set that integral equal to 20, that would be given to you as well. So there you have it. I always like to tell you the average on this one. The average for this guy was 3.42. So that's what a pretty good score would be. And there you go. Okay, let's do number 2. Good old chart problem. Another popular thing. So here we have it. Velocity, the velocity of particle P moving along the x-axis is given by the differentiable function v of p. So velocity of particle P, I guess, where V of P is measured in meters per hour and T is measured in hours. Okay, cool. Selected values are shown. Particle P is at the origin. Is there a time between that and that at which V of P prime of T, that's a lot to say, the acceleration of the particle equals 0 meters per hour per hour? Justify your answer. Okay. Sweet friends, when it says, is there a time? What are we supposed to think of? Is there a time? Is there a time? Those are the existence theorems. Now, which one should we think of? They gave me information about V of P and asked me about the derivative. So which one is that? That is the mean value theorem. Now, most people say, okay, well, look at the endpoints. I'm going to look at 0.3 and 2.8. Now, they were very nice in this one. It doesn't have to be that way because, well, let me just answer the question, and then I'll say my little spiel. Is that they kind of led you a little bit and they were nice. They don't have to. So let me just answer it. It says, would the acceleration be equal to 0? Well, the good news is 0 is so easy because let's think about what would have to happen. To be 0, these y values would be the same, and you can see that they are. So you know you're going to do mean value theorem. Remember, it's just getting it to, it's so hard to write all of it. This is how I would write it. Since Vp of t is continuous on the close. Now, how do we know it's continuous? Because they told me it's differentiable. It said that, differentiable function, so it has to be continuous as well on the open. Now, it's differentiable everywhere, but I was just getting the habit of writing that. And what? And the slope of the secant line, let me just write this out, 2.8 minus Vp at 0.3 over 2.8 minus 0.3. Again, you could write it that way, which of course is 55 minus 55 over 2.8 over 0.3. Because that equals 0, you're just saying that, hey, the slope of the secant line equals 0. You have a continuous differentiable function. The slope of the secant line is 0. Therefore, then by MVT, I like to put that, sounds like I know what I'm talking about, there must be a time in, now look at this, 0.3 to 2.8. Remember with NVT, these are open parentheses, even if this one is closed. There must be a time in there such that, and I'm just going to say the acceleration is equal to 0. Okay, again, you could say Vp prime of t equals 0. I'm just use the words because it's shorter to write. So what were the points? This one was worth 2 points. Again, the first one is, did you in some way find that you were looking to see that this is equal to 0? You saw that, that's +1, and then your justification using MVT. That means everything has to be written correctly. So parentheses correct. The wording has to be correct. Again, very hard to get both of those points, but if you kind of practice writing it out, you will be able to do that. The one thing I want to say that why I think they were nice is, guys, even if this problem had said between like 4, like, or 0 to 4, you know, doesn't matter the numbers. If it's 0, most people go, oh, I got to look at the endpoints. Yes, that's really nice when it's the endpoints. It doesn't have to be. And especially I've seen when it's 0, a lot of times it's not necessarily the endpoints because it is so easy to see, oh, I need to look for 2 y values that are the same. So I just wanted you to be aware of that. All right, letter B. Use a trapezoidal sum with 3 subintervals. They tell you the subintervals. Gosh, you got to read carefully because you're only going to right here. Don't know why, but that's just the way they wrote it. To approximate the value of that integral. Okay, so I'm going to write that How would I do that? Well, I know that my trapezoids, I'm going to kind of erase some of this so I can write a little more. I know I don't have equal heights. I know the spacing between here is 0.3. I know that one is 1.4. And I know this one is 1.1. Those are the heights of my trapezoids. I do like to pull out a 1/2, but I cannot pull out a common height because it isn't a common height. There isn't one. So I have to kind of do this big parentheses where I take the height of 0.3, and then I'm going to do, and I know I don't have to write 0 plus, but I'm just going to, so you're with me if in case it's not 0. That would be base 1 and base 2 of trapezoid number 1. My height of trapezoid number 2 is 1.4, and the bases are 55 minus 29. Notice that even though I can probably do that in my head, I'm writing it out. They like to see it, so I'm going to do it that way. And then 1.1, my two bases, again, negative 29 plus 55 or 55 minus 29, either one. And there you go. Now, here's the deal. I really could have left it that way. I could get full credit. Now, I want to put a units on it. Remember, it said V of P are in meters per hour. So if you integrate meters per hour, you get meters. Would you get full credit on that question for doing that right there? Yes, you would. Okay. And this is so weird to me that this problem is worth 1 point. Okay. And it's answer using the trapezoidal. So, okay, units, they probably wouldn't care on that. Now, if you got an answer, if you wrote an answer, which you're going to have to use that answer, I think, in a later question. So again, some people like to get the answer. That answer is 40.75 meters. Okay? So if you wrote that out trapezoidal and you added it up wrong in your calculator, I'm not going to type that in the calculator because it's a matter of typing. I don't think I need to show you how to do that. And you have the wrong number here, yeah, you don't get that point, which totally stinks. So some people would suggest leaving it. Again, you're going to have to get the answer in letter D. So, it's up to you. All right, let's do a second particle. I guess it is second particle. A second particle Q also moves along the x-axis so that its velocity is given by, and there you have that, meters per hour. Find the time interval during which the velocity of the particle is at least 60 meters per hour. Find the distance traveled by the particle. Okay, a lot of words. People, you read it through once, and then you start reading it again. When they give you a command, you do it. So a second particle has this velocity. Find the time interval during which the velocity of the particle is at least 60 meters per hour. In other words, I've got to find where VQ of T is equal to 60. And I'll go ahead because I don't want you to not know how to do this. So I will go ahead and get this on the calculator. Okay, so getting on the calculator, I have my equation into Y1. And then I have 60 into Y2. Making sure I typed it in right. That's always good to double check. Oh, see, I did not. Delete that sucker. There we go. Now let's talk about the window so I'm not fumbling around. It said T was between 0 and 4, so let's make that 4. And then if I'm going up to a Y value of 60, then I'm going to just do it a little bit bigger. I'm going to do 100. So I'm going to see where this is true. Notice I'm basically trying to see the time interval that it says it's above that, right? Find the time interval in which the velocity is at least 60. So I'm trying to find those two time intervals. Anytime you hit second calc intersect on your calculator, then you need to, of course, sorry, I'm talking and writing at the same time. I'm losing my train of thought. So anytime you're finding second calc intersect, you need to make sure you write down what equation is being solved. So that equals 60 at this time And I'm going to do second calc intersect again. And I'm going to, you know, what would probably be smart? I don't know if I'm going to need it, but just because that number is wackadoodle, I'm going to go ahead and store that number into I'm going to just have that number in case I have to use it again. And then I'm going to do second calc intersect, and I'm going to come over here, and I'm going to get this number. Boop, boop. So it equals 3.519, and I'm going to go ahead and I'm going to store that number into B. So I will have those in case I'm going to have to use them. Okay, so I have those two numbers. So what's my answer? They said find the time in which, so I'm going to write VQ of T is greater than or equal to 60 from, does it say greater than or equal to at least 60? Okay, so from, I don't think they would be that concerned with the endpoints, whether you use an open or close there. I have that. Perfect. Now, next question. I did that. Particle is at least 60. That means greater than or equal to 60. Find the distance traveled by particle Q during the interval when the velocity of the particle Q is at least 60 meters per hour. Well, good thing I saved those bounds because, again, I'm going to use Math 9, but I hope that you save those values, although I'm going to write down 1.866 and 3.519. Total distance traveled, of course, is the absolute value of the velocity. So I'm going to just do this. That's all I'm going to write on my paper. But in my calculator, I'm going to hit Math 9. Luckily, I stored, yay for me, those two values. And then I have that into Y1, but I need to do the absolute value. So I'm going to do second catalog, get that absolute value, and then put in Y1. Enter, and there you have it, 106.109 meters. Okay, here are the point counts. You get 1 point for this statement, for getting this. But friends, if you don't write like how you got those numbers, like if you just have that written on your paper, like, hey, these numbers, you won't get credit. You have to write down that. Then you also get a point for knowing that you are going to integrate this. So this integral with the bounds correct and the correct equation is 1, and getting to the final correct answer, remembering if you are off by even a thousandth, they do not give you that credit. So make sure you have all that correct. All right. Last one. At time t equals 0, the particle Q is at position -90. Using the result from part B and the function v of Q from part C, approximate the distance between the particles P and Q at time t equals 2.8. So you kind of have to think about what's going on, and obviously not that you have to draw this by any means, but you're like, okay, so particle, they're on the number line, right? It told you that particle P, I think, started at t equals 0. And so it's like he's going over here and he's traveling along here. And then he may decide, oh, he's turning around, and then he's going to go back this way. And then he's going to do this, and then he's or whatever. So it tells you that. It now tells you about, and then particle Q, I can't draw at the same time, but then particle Q is going along too. So particle P is going and particle Q is going. And at any instant, like particle P is over here and particle Q is over here, the distance between them looks like that. So you have to kind of think through, all right, how am I going to find this? Well, I basically need to know their positions because their positions are where they are on the number line. So let's work on particle P. Now, your writing doesn't have to be exactly like mine was, or mine is, but I'm writing it out so you're like, okay, that's what I did, but you need to make sure you label everything. The position of particle P at t equals 2.8, okay? Well, think about that. it said that it started at 0, and then it said using your answer from part B. Well, part B, if you take the integral of V of P, that's the displacement. So that's where that number, again, when you use the trapezoidal, although you didn't have to get it in part B, I kind of needed it in part D, is that, are you with me that the position of him is going to be equal to 0, his original position, plus his displacement from 0 to 2.8, which would give you, of course, 40.75. So that's where particle P is. So he's like, if this is a number line, particle P, not that you have to draw this, is way over here. Here's particle P at 40.75. Now let's think about what would be the position of particle Q. What does particle Q say? Or where is he going to be? It says that particle Q is at negative 90. So his position at 2.8 is going to be negative 90, where he was, plus his displacement. Remember, in part C, we found total distance. That's not the same thing. So I'm going to have to do this and see where particle Q is. So I'm going to go ahead and just do it at one fell swoop because I like to do it that way. Negative 90 plus the integral, math 9, from 0 to 2.8. And I think that was in Y1. Let's hope so, but without the absolute value. And that gives me, he's thinking. Come on, calculator. There you go, brother. 45.938. And so that's where particle Q is. So he's over here at 45. So obviously the distance between them P and Q at T equals 2.8. Sorry, my hand's hitting the color, so it's changing. Is going to be those numbers subtracted from each other minus the 40.75. And again, I'm writing 3 decimal places, but in my calculator, I have it all the way. This one was exact 40.75. And I get the answer of 5.188 meters apart. And this is my final answer. So what did you get points for in that one? You got a point for knowing to integrate to get displacement and getting the correct displacement for, or correct position rather, for Q. So did you know to integrate V of Q from 0 to 2.8? So if you wrote that integral down and got the right answer there for the displacement, I keep saying that, for the position of Q, then that is a point. And then did you get down to a final answer of 5.188 meters apart at 2.8? That's where they're at. Okay, that was a lot. I'm out of breath. What was the average on this guy? Ooh, not the best, but 2.83 was the mean score for that one. So again, I know you can get 2 points, 3 points. I know you can get that. Okay? Good. All right, we'll hit the other ones in a bit.